24?
Yeah.
What kind of freakiness this is here.
Is it potion?
Oh yeah, that's yummy. Something else we learned last time, real quick, just to make sure everybody's up to speed. What's the derivative of e to the x? E to the x. And let's see if you guys are paying attention. If I had this.
2x, ln of x.
Yeah. ln of 2.
If you follow that logic, this would be ln e, but ln e is 1. So that's why e is the base whose, when you make it a function, it's its own derivative. It's kind of nifty. And actually, I kind of gave a little bit of a proof of it, but the funny thing with the proof is, part of the proof is where we just go, we defined e to be that. That's what we defined e to be. So like we defined pi to be circumference divided by diameter. You take any circle, let's freak people out, of course. This circle, if you cut the earth in half, it's roughly circular. Take that diameter divided by its, or circumference divided by its diameter, you're always going to get the same number, no matter how big or small the circle is. Freak people out. They gave it the letter pi. E freak people out for different reasons. They have the letter E. So this one looks really yummy. Section 3.2 is where we learned product and quotient rule. And this is where I see neat stuff happen, like somebody says it's 1 over x minus x or something. Right? You can only split it up if it's a monomial on the bottom, right? You can only make it that easy to do. So don't come in knowing the algebra that we use in the world as it is now. Don't come in with some parallel world algebra. Try to pawn that off on me. Take the class in that parallel world, all right? And tell me how to get there. So obviously I use quotient rule. Who remembers this song? Yeah, that's all you need to know, because everything else makes sense. Of course, when I take this guy's derivative, it's going to be negative, because it's on the bottom, it's to a negative power. All the rest of it makes sense. It's just like product rule. So there's a minus in the middle, and it's over twice, square the bottom, because it would go to the negative 2 power if you made it into a product. So writing the rule out, it would be that prime times what?
X plus e to the x.
Good. Times the bottom.
Minus.
1
minus e to the x normal. X plus e to the x prime.
Yeah, so they each get a turn just like in the product rule. The top gets a turn first. The bottom gets its turn second. And then the bottom is just going to be itself. Square. I like it. And now, and trust me, writing the rule first and then attacking the derivatives is going to be so much easier to keep track of what you've done already and where things go. So who asked this question? Where's the trouble start? Did it already?
No, that part wasn't it. It was just the very last.
Okay.
I think when I had to combine all like.
So you catch me up on where you are. What's the derivative of this? What do you have to use here?
You multiply it to.
So I haven't taken the derivative yet, right? So derivative of this, how does that work?
You get negative x squared e to the x minus x.
All right, so let's focus on that. So here we go. All right, so that's where things went wrong. And I understand why, because this is like a hidden thing. People don't realize. Yes, it's a product rule. It's hidden in there because you're like, there's already a lot of shit going on. It can't be. Yes, it is. It's the product of two functions.
So x and e to the x, is that what it is?
Yeah, so I take the derivative of 1 is 0. Now I'm doing the derivative of negative x e to the x. And how does product rule work? It's derivative of the first times the second plus, and there's a negative through the whole thing. Is that right? Or I can just do that? X times the derivative of the second piece, right? Let me stop there for a second. So that is a product rule. That 1 just gets out of the way, but the minus stays there. So it's negative, the product will apply to this, times this. Right. the rules are very basic, but the functions that can be created can have multiples of those rules just everywhere. But every time you hit it, you just apply the rule. My whole world right there was this, with a negative in there, right? That was my whole world. Now, that sounds sad, Jeff. But right then, that's it. That was my whole world. I didn't care about it. And I did that, and then I go, oh, now that's there, and we keep going. This dude is fine how he is. Get rid of this piece is nicer. Kick ass all over this business squared. And again, please don't. Right? It's a minus sign. It can't go into just part of it. Now cleaning this up. X prime is 1. We get negative e to the x minus x e to the x times x plus e to the x minus, yeah, and it's no use, and now you just got to FOIL. There's this part's not going to have this in it, so there's nothing you can't factor this out and kill one. You might as well just start multiplying things out. Yeah.
How do you know when to stop using the product rule? Because wouldn't that be a product right there? If you're multiplying those two quantities. Yeah. Okay,
awesome. But right here, I'm taking the derivative of this, so that's not involved at all. Right? I'm not taking the derivative of this. I'm taking the derivative of this. And in here, now I'm focused on in here. That's the product.
Oh.
And it's been done. Do you see? So that's why it's so important to break this up into little derivative problems, because that can sometimes have multiple steps and they're their own problem. And then you just put everything back where it was. And you only attack the parts that you put primes on. That's why I asked you to write the rule first, so that you don't do like what you just said. It's a really good point. And everything else is like its own. That's done. It's just waiting. It's like, come on, man. All right, cool, maybe. And now this is algebra that's left. So you got to FOIL this out. There's a minus there. Be careful. FOIL this out. Yummy, yummy. And see what happens. I don't know. Hopefully something will cancel somewhere. That'd be nice. No? All right. I think you guys can maybe handle it from there, because now this is just crunch your teeth in that. Just FOIL it. Yeah.
I ran into something on the WebAssign, and it said, like, if you had a problem like 9e to the x, its derivative is still 9e to the x.
Totally.
Right. I mean, I understand that. I mean,
Good.
e, but like, if you had the derivative of 9e to the x, I mean, 9 isn't necessarily a function. It's the,
all right, gotcha. I'm with you. So if I had a function, what you're asking about is the product rule of this?
Would that be a product rule?
Sure, why not? Let me show you why you wouldn't do it. By doing it. You're going, oh shit, I'm never going to do that again. You ready? So if I did apply product rule, because 9 is a function, right? F of x equals 9 would be a flat line. It is a function. So this is a product of two functions. So sure enough, I would do 9 prime e to the x plus 9 e to the x prime, right? But what's 9 prime? 0. So I would never do.
Oh.
Coefficients just come for the ride. I mean, constant coefficients, right?
Okay.
They just come for the ride. Until they're alone, there's nobody in like, oh shit, derivative, I'm dead.
Gotcha.
Which is a really strange sentence. You can't be yet when you're forming that. I'll let it go. You weren't dead yet. I'm almost dead. All right. Yes?
58.
I go off on my own tangents. 58, section 3-2?
Yeah.
Oh yeah, this is good. I like it. All right. So, somebody had a good point earlier in my office there, saying you were going to do anything that actually applies to the real world. She didn't say it like that, thankfully, or else I would have taken it personally. But these kind of problems are nice because they step in and say, you're getting all these numbers, but when you put units with them, you have to be able to identify what the hell they mean. So when I take derivatives of functions that represent things in the real world, those derivatives must represent things in the real world. It's the way it's got to be. So this one gives me blah, 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 blah. So the quantity of this fabric that is sold is a measure this one here, the one about the fabric. The quantity of the fabric sold is a function of the selling price. Which kind of makes sense. When you change the price, you're going to sell more or less. The whole demand and so forth about, bless you, business, which I'm no good at. The total revenue earned. It's kind of this, I love this function. If this is the amount that I sell, and this is the price per amount. So let's say this is gallons of milk, and this is the price per gallon. What's my revenue going to be? That's kind of funny. How do you get the revenue if it's $3.50 a gallon and you sell 10 gallons? You've made how much money? Holy shit! What kind of store? So $3.50 a gallon and you sold 10 gallons.
Okay, well, I'm talking $350 for a gallon.
35.
All right, $35. Okay. Woo! Or that milk, that's got to be some magic milk. So it's the price per times the amount you sold, which is this. All right, so let me, and they give you this is the problem. This is all given to you in the problem, but I want to make sure you understand where that comes from. It only makes sense. The price per whatever times how much you sold. When you multiply, when you get that, it's the total revenue, the total amount of money we brought in. Right? Price per cup of lemonade times the number of cups of lemonade. Bam. $3,500. That's a pretty good day. Sorry, I'll leave you alone. So they don't tell you shit about what the function is. They just give you this. So part A says, what does it mean to say that f of 20 equals 10,000? Let me start there. And they do give us some, they said this is in yards, and this was fabric again. So this is in yards, and this is in dollars per yard. So they do give you some units, which is always nice. So let's start here. They give you, there's a second part of this about f prime. Let's do that in a second. Let's start with what should be the easy one. What does that mean physically? What just happened? What does this capture?
You sold 20.
No?
No, when the price is 20.
You know, when the price is $20 per yard, you'll have sold
10,000.
No, not sold 10,000. When the price is $20 per yard, what's this number? That's the revenue. Good, right? So let's back up a second. I'm thinking about revenue, not yet. This is F. It's my bad. So this is F of P. So when the price is $20, so it's not R yet. That's my bad. They're going back to F. When the price is $20, then how much did you sell? 10,000 yards. That's a lot. Holy shit. Okay, maybe. Because there are two functions up there. There's a function that's related to the quantity, and there's the function that's related to the revenue. Cool. I like it. So what does this mean?
You lost $350.
No.
Darn.
I like it, though. So again, this is going to be...
So is that the rate of change of yards?
All right, good. So I want you to really... What would this... All right, let's step back. Let's step back. This is a really good problem. So what does this... So F of P represents an amount.
Okay.
Right? Now F prime of P, this is interesting. Write it, now be careful. Write it in the other notation, the D notation. What would it be? It'd be D, DF, DP. Why is it DP? Because that's the variable, isn't it? Now let's tease this out. This is unit analysis. This almost feels like science class, probably because math is the most fundamental science. So it is science class. Unit analysis. What is F in terms of? What units?
Yards.
Yards. Change in yards per, and what's
Price.
Change it in dollars.
change in dollars?
America.
Dollars in America. All right. So what does this represent then? Let's go back. So this represents how the yards change, the amount of yards that you sell change as you change the price. In fact, I don't know if you realize this, but we're talking about specifically as I go this direction on the graph. That's always kind of like in the background, because we read in this direction. You with me? Hindu calculus, we may go the other way. We go this way, right? So if this were negative, that would mean my function, what would it look like at that point?
It would be decreasing.
It would be decreasing at that point.
Yeah.
So this represents the change, the rate of change in how much you sell per dollar, right? At any point. So when the price is set at $20 per yard, if I changed my price by 1, how much fewer yards would I sell? 350. That's what that represents. So the change in number of yards per price at 20 is negative. That means I'm going to lose. I'm not going to sell as many yards.
How would you state that, and like, how would you answer that? What does it mean?
That's what it means.
Exactly right. What you
Yes. Don't write just what I said. Try to see why what I said makes sense. That's the more important thing here, because you know I'm going to ask you a question like this on the next test. You know it's coming, because I'm making a big deal out of it. Right? You have to know what the hell you just did. Right? So when you take a derivative, you're finding a rate of change. You analyze the units to see what kind of rate of change it is, and then you can interpret any statement like that. Anytime you plug a 20 into the derivative, you get negative 350 out. What the hell does that mean? Well, what units does this have?
Yards per dollar. Yards per dollar.
Yeah.
So at 20, if I change the price by $1, I would lose 350. I would sell 350 less yards. I got to be careful. It's not perfect. It's the instantaneous change. So think about this. At 20, it's definitely got a negative slope, but we don't know right now. Is the slope getting even more negative? I don't know. All right, now let me see if you guys are with me. If I take a step of 1, so here I am, here's the tangent line. But if I step to 1, isn't that tangent line, isn't that getting steeper?
Yes.
Yeah.
More negative? Alright, so that's instantaneous, because the minute, and that's why the book made a big deal out of that in chapter 2, the instantaneous change in whatever. Because the minute you move, I moved, you didn't see me, but I moved. Now that number is different. If it is getting steeper, then that would become negative 351 maybe, or something.
So basically, like, when you're selling your textile, whatever, $20 per yard or roll, you're selling 350 yards less than you would at a different price.
This represents a change. So if I did change my price by $1, if that trend continued, I would sell 350 fewer yards. What's more than likely to happen is the trend is changing as I go further along. You see what I'm saying? So then I'd say, what would it if I changed it by a penny? Let me see if you guys can. So this is if I change it by $1, right? This is per dollar. I like saying the word dollar. I say it's a word. What if I change it by a penny?
$3.50.
Yeah, it would. No, careful. 3.5 yards.
Yeah.
And now stay with me. I am over analyzing this problem. Do you guys get that feeling? At the same time, you have to be able to do what I just said. You have to be able to tell me, well, when the price is 20, if you change it by a little bit, you'll sell fewer yards. Roughly 350. You don't have to go any deeper than that. That's what I want from you. That tells me you understand what's going on. Why would I want to do this? Why would I want to make it a cent instead of $1 change?
To get a more...
Because what happens when I go too far away from the point that I'm at?
Oh, you change the slope.
The slope changes by a lot. So what am I doing? I'm trying to stay close to it.
Yeah.
Because the closer I am to that point, the more relevant this number is. And I just change it, of course, as I change the units. I don't know if you guys are with me.
Wait, could you say what you just said one more time?
All right. What did I just say? I try to stay close. I try to stay close to where I currently am. So this says that I'm currently selling it for $20 a yard, right?
Right. And you want...
If I take a step of $1, then who knows what the slope what happens to the slope? Maybe my estimate is way off. And it's like actually, 1,000 yards. Oh, shit. So I want to try to stay close. I want to make small changes in my price. because I don't know what the real change might be further away from where I am. Because very often in business, you don't have a true function. You have observations. You have points. So you don't know really what's going to happen. All you know is locally what's happening. So you don't want to make a huge change in things.
Okay.
Because like, it might be, oh, it's going up. Let's do more. Oh, shit. We went up that cliff that we didn't even know was there. Shit. So you just want to change a little bit. Maybe. Anybody know about the position called a financial analyst? Anybody have that position in their future? You make a lot of money because you go insane doing this kind of stuff. My friend Sean, he makes so much money. He's got 5 kids though, so it all goes away. But he's a financial. He was with Dell for a while.
Analyze that.
Analyzing, just going insane, trying to suggest. One part of it is he suggests the price for certain things, or based on observations. He tries to piece together a function, and this kind of stuff. Obviously, he doesn't sit there and just crank it out. He's got software that does it, but he's got to interpret what the hell it's telling you. All right. Do they talk about the revenue eventually? Yes.
Yeah,
So what's R prime of 20? So again, take a step back. RP. So what's R prime of P? What's it in D? And revenue is in. Yeah. Now this is interesting. Revenue is let's say income dollars, right? And price is in. We'll say that's price dollars. So as I change the price, it predicts what my change in income is going to be. Income may be not the best word. Why not just stay with revenue, Jeff? Profit's not even really right either because I'm not even thinking about my costs. I got to make more fabric to sell it. Shit. So we'll just call this revenue. So how will my revenue change as I change the price that I sell it at? That's really what I'm interested in, right? Should be. So what do they ask? And then they ask, yeah. Oh, good. So in part A, they tell me this, and they tell me this. Do you know the function? I don't know what the hell the function is. Those are just observations that have been made. But part B, I love part B. Part B says, all right, it's nice. Find this. Find that. No, don't do that because we haven't even gotten anywhere near that. In fact, that's. What is R of P? Let's go back a step. What's R of P? All right, take a second to figure out what R prime of P is. What do you have to use? That's crazy. It's in the section of the product rule. You might expect it to happen at some point. So what this is getting at is something you'll get even more deeper into once we get to integration is a lot of the calculations we do, sometimes there's no function. There are just observations. And I want to try to see, can I still use the idea of calculus? Yes, as long as I can make the right kind of observations, I can put that together. I can still do this, even though I don't know any of these functions up here. Shit. I just have observations. But they're the right ones. Because what is the derivative of this?
P times F of P.
Well, P prime.
Right.
Yeah.
So what's P prime? 1. And let me really. All right.
Oh. Wait.
I've just taken away too much. But let me really now watch what's first. All right. Write this better for me. This is dr dp, right? Mm-hmm. All right. So r prime of p. Well, r of p was p times f of p. So r prime of p is d. All right, let me stop there for a second. Let you guys catch up. That's why that notation is actually, the prime notation is nice when you're learning the rules and such, because you don't want the d stuff to be in the way. You want to just focus on the rules. When the variables start to change, and in fact, when you get to multivariable calculus, and then you got to be really careful. Do you want me to take the derivative of x or y, or what the hell is the real derivative, the real variable? Well, here the variable is b. So when I take the derivative of this piece, dp, what is that? Get out. Kick ass. Come up plus sign. All right, that's what it really looks like. That's yummy. You see how this is the derivative of the first piece? Times, leave the second alone. plus, leave the first one alone, times the derivative of the second piece, right? That's the product rule. But written not in prime notation, written in...
Can you just use the prime notation?
Totally. For right now, I'm just doing this just so we get used to the fact that it's not x's, right? It's p's. That's why p prime, which is dp, that's 1. And so then I get dr dp equals f of p plus p times f prime of p. And so what's r prime of 20? All you have to do is plug a 20, plug it in. And you know f prime of 20, they told you what it was. You know f of 20, they told you what it was. You can just plug it in.
Oh.
Cool. I like it. Take a second and do it. Let's see if we all get the same answer.
Maybe 3,000.
So let's see. Let me make sure everybody's with me.
20 times.
This is f of 20 plus 20 times f prime of 20. What was f of 20?
10,000.
Cool. 10,000 plus 20 times f prime was the negative 350.
Times 20.
So it's 10,000 minus 7,000, right?
Yeah, 3,000.
3,000. And so we got r prime of 20. Turns out to be 3,000. What does that mean?
$3,000.
Is it a good idea to increase the price if you have it set at 20? Well, you can do it. You can do it. Is it a good idea to increase the price if you have it set at 20?
No.
What does this say? What's going to happen to my revenue function as I move forward from 20? It's going to go down. It's positive.
So it's going up by 3,000?
Yes. When you take the derivative of something, what do you get? The slope. The revenue function, what does it do to make me happy? Revenue function has to go up. I got a positive output. That means if I do change the price a little bit, then I can expect my revenue to increase. Now remember what... Get out of here. Where are we at? Here. Wasn't R prime... Where'd it go? F prime. Yeah. F prime of 20. Wasn't it negative?
350, yeah.
And that means I was selling less. I was selling less, right? I was selling less. But why does my revenue still come out?
Because of the demand.
You're selling it for more money. You're selling it for a higher price. So if you only look at one piece of the revenue, it's going to give you the wrong idea. If you only look at your cost, it's going to give you the wrong idea. You actually, and this is not even good enough because I want to look at my profit function. That's what I should be looking at. That's not what they didn't give me any cost information. But if I was just trying to maximize my revenue, it's all I was trying to do. I want to go in that direction. I want to increase my price because that tells me it's got a positive slope in that direction. Yes.
Now, let's say that we were given also that revenue at 19 and it was a higher price. So let's say it was 3,500.
And be careful, be careful, be careful. I like it, I like it. I like where you're going. So if R price prime of 20, like we just said, is 3,000, and R prime of 19
was like 3,000.
All right, now I want you to be careful. This is not a amount of money. What is this?
It's a trend of it increasing.
Change in my income per. So if I was at 19, it would be even more imperative to me to write. So let's say I was at 19 and I raised the price up and then I made more observations and I saw this. I'm going to keep doing it and I'm going to go to 21 maybe. And if this suddenly becomes that,
maybe go back a little.
Maybe go back a little. Or maybe just stay there because it tells you if I go forward a little bit, my revenue's going to become less. So maybe I'm okay where I am.
Yeah, but from 19 to 20, the trend it's still accelerating, let's say, or it's still changing, but
it's still going up, but it's not going up as quickly. So my revenue function, where of course is the best place to be on that function?
The top.
Well, the top. No. And what's happening as I get closer to the top?
The slope
is getting
closer to zero.
So how do I know I'm at the top? If I take one more step and the slope becomes
zero.
Negative. Now if it was zero, that means I'm right at the top. But that is a moving target. So if I calculated this, I would tell him, stay right where we are. don't do shit. And then the terrible thing about the job is, tomorrow everything will be different. And then I start over. Okay, sure.
The idea will be to get 0. Yeah.
Because what would that mean? Hopefully that would mean you're at the right peak.
Maximizing.
Because in reality, revenue normally is not just a parabola. It is locally sometimes, but in reality, revenue might have several peaks and troughs. So like, oh, it's 0. I'm going to stay. Oh, you're losing money, Johnson. I'm going to have to fire you and find somebody else that knows what the hell it is. Right? So you could be happy here, but without realizing, oh, there's a higher peak. There's a higher peak. Anyway, right now, I just want you to start to realize what you can do with this, the interpretation of it, right? Always remember when you take a derivative, that is a rate of change, that is a slope. And if you just stop yourself and look at the units, it'll make even more physical sense. Just look at the units. And that's why this notation is really good for that. Write it in this notation, and the units just pop out at you. Well, what's that in? What's that in? Bam! Now I know the rate of change of this with respect to whatever. Gas. Half you guys look really, well, actually most of you look down. I'm sorry. I thought that would be good. Oh no, sorry. Anything else from homework? Yes?
I gotta go right now. Where are you going to be teaching? So I can
We're going to go over that handout from yesterday. Did you get the handout?
you were in class yesterday.
Not yesterday, but you know, relative to class time. Whenever I say yesterday, that's what I mean. Anybody need that, by the way? You good? You good? Oh, I'm sorry. All right. That's a lot. So I'm sorry. Was there any questions from the homework? Oh no. All right. So let's do this. Let's. Did anybody have a chance to work on this earlier? It's kind of good if you didn't. If you did, it's great. Group up and work on it. Get together with other people. What? Other people? If you're really against the idea, you could be a wolf pack of one, but it'd be nice if you could bounce ideas off other people.